Hello everyone, welcome back to another episode. And in this video tutorial, the MATLAB code appears to be a power flow analysis for a Nordic 32 bus system, including the wind turbines and PV generators. So let me summarize this code via the sections. So previously I have designed another code which is on IEEE 33 bus system, which is actually a radial bus system. So that video use the backward forward sweep load flow analysis, and I will put the link in the description and in the iCard in the top right of this video. And in this video tutorial, the network here you can see on the right side, this is a mesh network. So the load flow analysis considered here is Newton Raphson load flow analysis. So let me break down this code into different sections. So the first section, the code starts with the bus and line data definition, or with the line and load data. So this section actually initialized the bus data right over here and line data next here. So for the power system, the bus data actually includes the information about each bus, each 32 buses, such as voltage magnitude, angles, and loads. And on the other hand, line data includes information about the transmission line, such as its resistance, reactance, and admittance. So this is the end of the first section, and in the second section, right over here, at this point here we just change the variables data and put the data into another variables. These variables will be utilized right over here in the upcoming code. So the second section starts right over here, which is about the bus admittance matrix calculation. So in this part, the code next from this line calculates the bus admittance matrix, such as which actually represents the network's electrical characteristics. It calculates both the diagonal and off diagonal elements of Y bus based on the line data and the configuration of the network. So next over here, here is starting of the after the ending of the bus admittance matrix calculation. Right over here, next section starts, which is about the power flow solution using the Newton Raphson method. So Newton Raphson method initialized here in this section. So this is actually the heart or the main part of the power flow analysis. The code used here, Newton Raphson method, to solve the power flow equations for each bus. Actually, it's based on the iterative updates, which update the voltage magnitude and angles until the convergence. And this section also computes the power generation demand and the reactive power, taking into account the generative constraint and the bus types. And also it includes the swing bus and the generator bus. So after that, the next section starts, which is about the printing power flow results right over here. So here in this section, so it's after solving the power flow equations, the section prints the results on the screen. It displays bus numbers, voltage magnitudes, angles, loads, and generator output. Let me click on run. Let me click on continue. So it also shows the total power losses in the system. Let me show you all the results. And in the next part, which is actually the line flow and loss calculation, from here, after running the this program, the line flow and the loss are displayed here. And also the code calculates the flows, line flows and losses by analyzing the current and the power flow through each transmission line. It prints the results for each line, including the power flows and losses. So right over here, after that, here we have a plot which actually, on the one side of this plot there is magnitude of the voltage, and on the other side number of buses, which are actually the 32. So this section creates a plot that shows the per unit voltage profile of the network. So overall, the code is used to analyze the power flow in electrical network, helping to understand how electricity flows through the grid. So calculate the losses, the and optimize system operations. It's a critical tool in the power system analysis and planning. So that's it for today, and like the video and subscribe the channel. Thanks for watching.